If you thought space already had its fair share of terrifying places, think again. We've discovered scorching hot planets, inhospitable gas giants with winds faster than 500 miles an hour, and black holes themselves. But these celestial objects have characteristics. Imagine a place that's literally just a void, a gap in space that has absolutely nothing and stretches millions of light years. Scientists have found such a gap, and it defies all logic. But do we know anything about this gap? Or are these questions going to be unanswered? In 1981, Robert Kirshner was working with other astronomers at the University of Michigan to calculate the redshifts of a great number of galaxies. If you already didn't know, redshifts are the wavelength of the light that is stretched, so the light is seen as shifted towards the red part of the spectrum. Basically, it's a measurement of how fast something is moving away from Earth. So, due to the way our universe is expanding, the farther away a galaxy is, the faster it moves, meaning redshift can be used to measure distance. Kirshner and his team were using this method to create a 3D map of the universe. As the map became rendered out, something weird appeared. At 700 million light-years from the Earth was a blank void in a somewhat spherical region around 330 million light-years wide. To put that into perspective, the Milky Way could fit into this region billions of times over. There were barely any galaxies in this region. Initially, the region was dubbed the Great Nothing, but later the region's name was settled on the Boötes Void, as it appears to lie in the constellation of Boötes, named after the Greek word for the herdsman. 41 years later, and surveys have managed to create more detailed maps of our universe. We now know that arrangement of galaxies resembles a giant web. The majority of galaxies in our universe are found in long structures known as filaments that wind through the cosmos. When these meet, they create regions with high concentration of galaxies known as clusters. Between these threads, however, are huge, empty voids with hardly any galaxies in them. Surprisingly, the voids make up around 80% of the observable universe, and most of them are around 30 to 300 million light-years across. Boötes, though, is one of the largest, earning it the title of supervoid. That kind of sounds like a great name for a band. Think I should write that down. Anyway, it's thought that Boötes is the product of smaller voids merging together. It's strange to hear that there's more nothing than something, if you get what I mean, but what actually causes this to happen? Well, the cause of these voids is thought to lie in the origin of the universe. In the early days of the cosmos, all the universe's matter was tightly packed together. This is thought to have been a uniform soup. But with random quantum fluctuations, soon small differences were created in the distribution of matter. As we're finding out now, some areas were slightly more dense, meaning their gravitational pull was greater so that they pulled matter away from the less dense areas. This made them even denser, increasing their gravitational pull again so they attracted more matter and so on. While this was happening, at the same time the universe was expanding greatly, and so these fluctuations that started on a quantum level eventually spanned across hundreds of millions of light years. Smaller clumps of matter, on the other hand, began to organize themselves into galaxies. By studying these large structures, astronomers can gain a window into what the universe looked like in its earliest moments. Today's advancements in both telescope and imaging technology will help us create more detailed versions of Kirshner's maps, such as the Dark Energy Survey, which has mapped out a quarter of the southern sky, examining around 300 million galaxies. We're fortunate to now have supercomputers that can create detailed simulations of how the universe has grown from those first moments after the Big Bang up until the current cosmos that we see today. By comparing these maps with the simulations, astronomers can begin to understand how our universe came to look the way it does today. The Boötes void, as we mentioned before, is around 250 to 330 million light-years across and is one of the largest voids out there that we've discovered. So far, only 60 galaxies have been discovered in the Boötes void, and all of those are found in a tube shape running through the void. Let's put the Boötes void into perspective then, shall we? If you consider the distance between us and our closest galactic neighbor, the Andromeda Galaxy, that's about 2.5 million light-years away. It would only cover about 1% of the Boötes void. If we use a rough estimate of about one galaxy every 10 million light-years, that's 4 times farther than Andromeda. There should be approximately 2,000 galaxies in the Boötes void. Expressing the vastness that is the Boötes void, astronomer Greg Aldering said, "If the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies." That's a little too terrifying. Currently, scientists are unable to explain how the huge void, which lies between the constellations Perseus and Taurus, might have formed. There are several such empty bubbles in the universe, just like the Great Nothing or the Boötes void. While they might not be able to confirm, there will always be several explanations for all of space mysteries, and these gaps definitely have their fair share. Among the wildest is the suggestion that an extraterrestrial supercivilization could have built power-harvesting Dyson spheres around a vast number of stars, blocking out their light. That, as you may already have thought, is the least favored theory, but it is still plausible. In science, though, there are often more questions than answers. Study leader Shmuel Baali, a postdoctoral researcher at the Institute for Theory and Computation, or ITC, at the Center of Astrophysics, has a couple more explosive ideas, saying, "We have 2 theories. Either one supernova went off at the core of this bubble and pushed gas outward, forming what we now call the Perseus-Taurus supershell, or a series of supernovae occurring over millions of years created it over time." If his information is correct, he says, the existence of this empty space demonstrates that when a star dies, its supernova generates a chain of events that may ultimately lead to the birth of new stars. The gigantic bubble was spotted while researchers were analyzing 3D maps of molecular clouds in space created using data from the European Space Agency's Gaia Space Telescope. Postdoctoral researcher Catherine Zucker said the 3D maps were giving astronomers a brand new perspective on the structure of the universe. She explained, "We've been able to see these clouds for decades, but we never knew their true shape, depth, or thickness. We also were unsure how far away the clouds were. Now we know where they lie with only 1% uncertainty, allowing us to discern this void between them." She went on to explain that there are several theories for how these molecular gas clouds go on to give birth to new star systems, saying, "Astronomers have tested these theoretical ideas using simulations in the past, but this is the first time we can use real, non-simulated 3D views to compare theory to observation and evaluate which theories work best. And with these non-simulated 3D views, hopefully, we get some solid answers." So, what do you think is in the Boötes void? And what more will modern telescopes and technologies reveal about the Boötes void? Let us know in the comments below, and like always, thank you for watching Space Rumor.